So today we are starting the last of the scripting languages we're going to talk about in the class. So we're moving now from the server side to the client side, and we'll be talking about how you add interactivity to the browser side, and we're going to talk about the most commonly used client-side scripting language, which is JavaScript. And JavaScript is very much like C and C++ in syntax, so I'm not going to bore you with all the details of the syntax of the language. You should be able to go through the textbook and see very quickly, in fact, how the language is structured. What I'm going to talk about are the ways it differs from C and C++, and there's some important differences and features it has that you should be aware of. So first of all, kind of where it fits in. When the World Wide Web was invented in the early 90s, it was static. Web pages didn't have interactivity associated with them. They were, in effect, something that was presented, you read them, but you couldn't interact with the web pages. And Netscape, which at the time was the most widely used browser, wanted to add interactivity to web pages. And so one of their programmers came up with this scripting language, which he named JavaScript. And it has nothing to do with Java. It was just Java was hot, had been introduced a few years before, so they figured it was good marketing. If they named it JavaScript, everyone would say, ooh, Java. And it would be more readily adopted. But in fact, it is more like C and C++ in character than it is like Java. And as we will see, its class model is totally different than C++ or Java. At any rate, the idea with JavaScript is that you should be able to interact with the browser through mouse clicks, through keyboard events. And before you had JavaScript, you had interactivity through forms. So you already had ways to enter information through forms and send that information to the back end. But they wanted to give you additional ability to manage things in the forms, like ways to enable or disable radio buttons, or enable or disable parts of a form, or change the colors of form elements, for example, if you entered information incorrectly. So they wanted to give you ways to have greater interactivity with forms, but also with other parts of the web page. And they also have the ability, for example, to have scores or quotes or other things constantly be updated on your web page. And for these reasons, JavaScript was introduced. So JavaScript was never meant, like PHP, to take input from the console or output to the console. So just like PHP, JavaScript has very limited I/O facilities in the sense that you understand them. Instead, JavaScript, the input it takes is through events. So for JavaScript, okay, the input mechanism is meant to be events. Meant to be events like mouse or keyboard events. Rather than text input from the console. And the output, instead of outputting to the console, is meant to be changes to something called the HTML DOM. Okay, the HTML DOM stands for Document Object Model. So every web page is parsed into a tree. That tree is called the Document Object Model. And all the markup is either interior nodes, well, is in interior nodes, and then the content is the leaf nodes. And what JavaScript is able to do is modify this tree by changing either the markup tags or the content. And then the browser, the way the browser displays a page is by walking this document object model and drawing the display based on what it sees in the document object model. So when you make changes to this tree, that actually causes changes to the page, HTML page that's displayed. So on Thursday, we will be talking about that, JavaScript in the browser. We'll be talking about the DOM, the JavaScript DOM, how events interact with it. So today, part of the reason today's lecture is short and sweet is because today's lecture is more just what is the language itself. And Thursday is how does this language deal with events? How does this language deal with changing the HTML DOM? Okay. So that is basically JavaScript in a nutshell. It provides ways to change things. So for example, you may see in you might say something like input, in a form you might say input type equals, say, submit. And then you might see on click equals, and then you might say something like document dot get element by ID, say foo dot color equals red. So that's this right here is some JavaScript code. What is happening, should have another single parentheses out there. The onClick is an event. It's saying that when that onClick event is arrived, document is a pointer to the document object model or tree for that page. We are getting an element whose markup or whose ID identifier is foo. Actually, it's not dot color, it's dot style dot color. So what I'm doing is setting its dot style, the color attribute in its style object to red, and that will turn the content of that element to red. So that's an example of using JavaScript to modify the appearance of the web page. But you must crawl before you walk. So crawling in this case means understanding the basics of the language. So the things that you should have already read the book for today and done the participation activities. So there's just a few things that I really wanted to point out. First of all, you do need to debug, obviously, and when you debug, it's kind of inconvenient to just have the output be a modified web page. So there's two ways you can kind of look at output from a JavaScript program. First, there's a so-called, if you give an alert function, there's an alert function, and if you give it a string, it will pop up a dialog box with that string and actually stop the JavaScript program until you hit OK. So one way that for debugging is you can use the alert to pop up a dialog box with the values of things. The second is you can say console.log and give it a string. Now, you need to know where to look to find that output. So in Firefox, it varies from browser to browser, but in Firefox, if you go to Tools, you go to Web Developer, you will see something called Web Console. And if you go to that, that is where you find output from a JavaScript program, if you have done console.log. Also, most browsers have a way of creating very simple JavaScript programs and testing them. For Firefox, it is Scratchpad. So if you, under Web Developer Tools, you select Scratchpad, you get a little window that allows you to enter JavaScript. So you can just enter very simple things, a equals 10, console.log, a equals plus a, and then if you run it, you see over here, hopefully a equals 10. Okay, we all see that over there on the console. So it didn't show up in the window, but when I hit run, it ended up over here. So that's another way that you can do it. Or I could have said alert, and now it pops up a window, a equals 10. Okay, so those are two ways that you can do debugging in JavaScript. And also, if you want to just write a small JavaScript program to test it, that's a good way, at least in Firefox. Chrome and Safari, I believe, have similar kind of Scratchpad things where you can write small one-off JavaScript programs to test it. But it is harder to test a JavaScript program than it is a PHP program because I don't know of command line interpreters for JavaScript. Okay, they may be out there, it's just I've never dealt with one. I've always only dealt with JavaScript from within a browser. So it is harder to debug JavaScript programs. Fortunately, they tend to be shorter as well, because when you're responding to an event, you don't want to start something running for like 5 minutes and freeze the browser. You want whatever you do to respond quickly to the event. If there's going to be something that takes longer, you would normally send that off to the server, let it crunch on it, but you don't want to freeze the browser. You don't want to make it look to the user like the browser is frozen. So normally whatever you do in response to an event needs to be very fast. Okay, so you're normally not writing huge JavaScript programs. Okay, so that's debugging. Now, another thing with JavaScript is its functions. So functions, very natural. Give it a function keyword in a name, like foo. But there is one small issue. You remember you don't have to declare your variables in scripting languages. In JavaScript, you can do it using what keyword? Var. So let's say you do this, a equals 10, and now you also have, let's see, foo, and you say alert, a equals plus a. If this were a normal programming language, what would happen at this point when you try to print out a? Pardon? It's not been declared. You get a compile error message. Okay, well, let's try that because that's not what's going to happen. Okay, so we call function foo a equals 20. We'll call foo and we'll run it. A equals 20. What happened? What obviously a is equal to 20, but can someone describe more generally what is going on here? What has happened with a? What would normally happen with a when the function returned? It would disappear, right? It would go out of scope, but it's not. So this is what you have to be careful about. In JavaScript, if you don't declare a variable in a function, it's put in the global namespace. If you don't declare it, if I change it, now watch what happens. If I now say var a equals 20, okay, so now I declared it as var a equals 20. Oh, come on. That's not supposed to happen. There we go. I think A was 20 because it hadn't lost its memory. It wasn't running it from scratch. So A was still 10. But you can see now var A equals 20, but the value of A has stayed the same. Now let me get rid of the var and run it. See the difference? A is 20. So you should be careful in JavaScript to declare your local variables with var, because if you fail to do so, the variables get put into the global namespace. Okay? That's not true of PHP. In PHP, if you don't declare the variable, it doesn't matter. It's assumed to be a local variable in the function. In PHP, you have to prefix a variable with the word global if you want it to refer to be placed in the global namespace. So JavaScript and PHP are different that way. Okay? And this has bitten me in JavaScript. The reason I'm so aware of it is that when I was new to JavaScript, that killed me, because unexpectedly, global variables were changing for no good reason. And that was it. Okay? So make sure you remember that little nugget. Okay? Before I forget, this is another important thing. When JavaScript was designed, it was designed so that people would feel comfortable downloading a JavaScript code fragment onto their computer from an unverified source. Now, in general, how would you feel about downloading a piece of code from an unverified source? Not real good about it? Like maybe in another minute or so, your bank account might say 0. So when they designed JavaScript, they needed to make it safe so that you would feel comfortable with having arbitrary JavaScript code execute on your computer. So what do you think, I'll throw it out there. What would make you confident or comfortable about running something on your computer as far as that you could be comfortable knowing it wasn't stealing your information? What would you have to guarantee the language could not do? Access your file system. So essentially, JavaScript, as originally designed, could not read or write to this file system. All it could do was hold stuff in memory. Okay, so if you can't read or write to the file system, you can't get access to your bank account or your passwords or other things. Now, there is something that JavaScript can read to and write from, and we've talked about that. Does anyone remember what special memory is associated with a browser, if the user has permitted it, that JavaScript is allowed to read or write from? Sorry, write to, read from. Cookies. So the exception is cookies. And there's something now called web storage, so I'll just say exceptions, cookies, this concept called web storage. But these are, in effect, sandboxed, so I'll call them sandboxed areas of the file system. So it's set aside effectively for the browser but you can't get access to your personal file system. And you also should not be able to get access to cookies left by other domains. So if I write one from web.eecs.utk.edu, Amazon should not be able to read my cookies and vice versa. So there's supposed to be some security in here that doesn't allow for the reading of cookies by other domains. This is sandboxed off. There's limits on how much storage there is. But that was the big restriction on JavaScript, is not being able to read or write to the file system. Now, there are other things there, the lack of pointers. Every scripting language essentially has pointers but doesn't let you access them. So you can create new objects in Python or PHP or Perl or JavaScript, and what you get back is a reference to it, but you can't do anything to it. You can't do pointer arithmetic on it, for example. So at any rate, this was the big security feature in JavaScript that makes it okay to have it downloaded. So there again, it doesn't have the traditional read or write abilities of a normal scripting language. So in some sense, JavaScript is weaker than almost any other programming language that you will deal with because of its inability really to do any kind of meaningful reading or writing to a file system. Okay. So make sure, I'm not going to really go over regular expressions because JavaScript regular expressions are just like PHP regular expressions. They're taken from Perl. But make sure you've read up that section so that you know how to use regular expressions in JavaScript because they're useful for type checking form information. The thing I do want to talk about is JavaScript's class mechanism because it is utterly different than the C++ and Java class systems. In fact, pretty much all scripting languages use what is called a prototype instance model rather than a class instance model. So scripting languages use a prototype instance model. Compiled languages like C, C++, JavaScript use a class, well, C is not really an object-oriented language. Use something called a class instance model. So what's the difference? In each case, so the class in a prototype is effectively an object that is a template that you can use to stamp out instances. The difference is that with a class, the structure of the class is immutable. It's set at compile time. When you say class foo and you give it some variables like int a string b, that's it. It is the compiler can set out a memory structure for your class. And you will not be able to add new instance variables to instances of foo. You will not be allowed to delete those instance variables. You will not be allowed to modify the methods. You will not be able to add new methods, nor will you be able to delete methods. So the entirety of the class is defined at compile time in a class instance system. In a prototype instance system, that's not true. Everything is mutable at runtime. So at runtime, in a prototype instance system, you can add or delete instance variables from the prototype. You can add, delete, or modify methods. which makes scripting languages much more flexible, okay? Especially for testing purposes. If something goes wrong, instead of having to start a program from scratch, you can simply modify the method, assign it back to an instance variable which represents that method, and start the program back up without ever shutting it down. So in practice, I don't think you really tend to make much use of this facility of being able to add or delete instance variables from the prototype, or being able to add or delete or modify methods, but the flexibility is there for you. Now, what does that mean as far as efficiency? It kills your efficiency, absolutely slaughters it, okay? Because in a compiled language, we know at compile time how to lay out the record, and we know what the offsets are. So we know, for example, that every instance of a foo will have an A at offset 0 and a B at offset 4. And we can set up our variable accesses so that they access, if I say something like x equals foo A, then the assembly code knows effectively that this is equal to foo plus 0. Or if I say x equals foo B, the compiler knows that that is really x equals foo plus 4, or the contents of foo plus 4. That's not true in a prototype instance language. You'd have no idea what the format of the variables might be, what the layout might be, because they can change. Not only can they change the values, they're not, A doesn't have to be an integer. It could be assigned a string. It could be assigned a bitmap. So you can't also assign any variable a fixed amount of storage because they're dynamically typed. So does anyone know how instances of objects are stored in scripting languages? What data structure is used to represent objects? Is it, pardon? Dictionary. Okay. I know I'm being pedantic. There's a technical difference normally between a map and a dictionary. So typically when we say dictionary, we mean hash table, and when we say map, we mean tree. Okay? So in fact, in JavaScript, there is there is a map object in JavaScript, and it guarantees that the key value pairs are stored in order, and it is a tree implementation, whereas the object implementation uses a hash table. So be careful with what you say. When you say map, people actually are going to think ordered implementation using a tree. When you say dictionary, they're going to think hash table. Okay. So, in fact, objects in prototype instance systems, i.e. in scripting languages, they're implemented using dictionaries. So every access to a variable is actually done through hashing, which obviously isn't as efficient as having a direct memory access. In fact, it's a lot slower to do a hashing access than it is to do a direct memory access. Okay, so that's what I mean by the performance is a lot slower. Okay, so a lot of flexibility for the programmer in terms of being able to add or delete instance variables, but a corresponding lack of efficiency, which is why you don't try to do big programming projects in JavaScript or PHP or Perl, even though people do. Okay, so let's just take a quick look at that because it is different. Okay, unlike the other stuff, the syntax is going to look weird, and I want to walk you through it. That's not it. This is it. Okay. Okay, so you start out with, first of all, with normal JavaScript, the constructor is, this is actually a class. We're creating a class. Just from the function, we are creating a class. And the way that JavaScript knows that this is a class associated with a class is the this keyword. So this is a pointer to the object. And this is the constructor function. Nowhere does it say that it is a constructor function, okay? The only way JavaScript knows is as it executes it, it has the this command. So when you actually create an instance of an object, you say new. So now JavaScript says, okay, I know I'm allocating an instance of an object. Then you give it the name of the function. That function better contain references to this, because if it doesn't, you're not modifying the variables in the function. I'm sorry, you're not modifying the instance variables. You're modifying what? If I just say name equals, or if I were to say n equals name, what am I doing with n? Global variable. So you have to prefix stuff with this, unlike in Java or C++, where you know what the names of the instance variables are because you declared them in the class. Okay? You haven't declared any variables anywhere. So the only way JavaScript knows that name and age are supposed to be part of the instance, they're supposed to be instance variables, is because you prefix them with this. You don't do that, you're creating a global variable. Or if you say var, that's okay too, but you're creating a local variable. You're not creating an instance variable. So say this dot. Okay? And you'll notice that you can assign functions to variables. These, you'll often hear the word properties used. So often you'll hear name, age, and say hello referred to as properties. Okay? So that's another difference between prototype instance models and class instance models. In class instance models, we tend to talk about member variables or instance variables. In prototype instance models, you'll tend to hear the words properties used. Okay? But properties is the same as an instance variable. So in scripting languages, property, whoops, we're back here, prototype instance, but in prototype instance models, the term property is often used to describe an instance variable. So when people talk about properties, they're really just talking about instance variables. And a property could be a method as well. So that's what you're seeing here, is that we're assigning a function, and you'll notice the function is unnamed. There's no name after the function. So JavaScript makes big use of unnamed, so-called unnamed functions. It's just assigning, that creates a function object, dynamically creates a function object, and then returns a pointer to it, which is stored in say hello. And then notice down here, you can just access say hello and pass it whatever parameters you would. Okay? Now, with this, I actually just created an object. I don't yet have a prototype. This thing doesn't have a class. It's not a class. Doesn't have a prototype. Okay, so if I want to create a prototype, then what I do is there is a property called prototype associated with the function. So the function has a property called prototype. It has an object automatically created for you, which is initially empty, representing the prototype for this object called person. And now what I've done is assigned the method say hello to the prototype rather than to the object. This is important. The importance is that if you do it the way it's done on the left, then every instance has this property and this pointer. So it has storage for this property and a pointer to this function. In contrast, over here, you only have all instances share this property and this function. So instead of having one property and pointer per object, you have one property and pointer for the entire set of person objects. So generally, you want to assign your methods to the prototype. Same thing, if you want there to be a so-called class variable, which in C++ is static, you would assign it to the prototype. And then it would be shared by all of the instances. Okay? But, watch. Actually, it's not so easy. You're allowed to override, if I put, let's say I say person.prototype, let's say I said person.prototype dot, let's see, favorite color equals purple. And now, down here I say Pam dot favorite color equals green. What do you think that modifies? What would it modify in C or C++, I'm sorry, in C++ or Java? Come on, you should know this. Pardon? It should in C++ or Java, it should modify the class variable. So Pam.favoriteColor should set the prototype's favorite color to green. That doesn't happen here. You want to change the prototype's color to purple, say green, say person.prototype.favoriteColor equals green. This will create an entry in Pam's dictionary with the name favorite color, and favorite color for Pam will be green. It will continue to be purple for every other instance of person. This is different than a class instance model. Okay, so Pam, this statement only modifies it locally, creates an entry in Pam's dictionary for favorite color. It does not change the prototype. Now, that means if I now say delete Pam.favoriteColor, that may also have counterintuitive implications. You may think that Pam no longer has a favorite color. You would be wrong. Pam's favorite color is now purple. So the way things work is if you first look for a variable in the local dictionary. If you don't find it, you go to the prototype. If you don't find it in the prototype, you go to the prototype's prototype. So in that sense, it is like a class hierarchy, right? In a class hierarchy, you might have class foo, and it might have int a, and then you might have class goo, and it adds a variable int b. So if you have now a reference in goo to a, you first check goo, it's not there, now you go up to a in effect. Same thing in a prototype instance model. So if something's not there locally, you go up the inheritance hierarchy. Yes, Ben? Pardon? What if you want a shared property, like all rectangles on the screen should be green or all rectangles should be black? You're enforcing, in some sense, this idea that all things have the same color. And it's great for prototyping because you go to a customer and you say, okay, do you like this look better? And you show them that. And then you say color equals black, and now everything changes to black. Do you like that? As opposed to having to change it on a per instance basis. So that's part of the advantage, flexibility of the prototype instance model. Okay, so again, you can dynamically add new variables to any object. You can dynamically delete variables from any object. Okay, so questions about any of this thus far? Okay, so now let's say you want to create an inheritance. That is kind of complicated. Okay, so I want this child class student. I have the superclass person. So there's 3 steps. First step is in the function, the constructor function for student, I explicitly have to call the superclass. No super, it's person. Whatever this explicit name of the superclass is, and you say call. You don't just say person, you have to say dot call. That's a property of person, passing it this and the name. Why do you have to pass this? Because person expects a pointer to an object. Remember, when you call new person, new passes in a pointer automatically. So if you call the person function, you have to explicitly pass in a pointer to the object as the first parameter. So that's step 1. You explicitly call, so step 1, this is making a super, actually not put it there. So making a superclass, or making a subclass, one, call the super, I'm going to say superclass, I can't get away from it. Call the superclass function explicitly using the name of the superclass. So e.g. person.call. Okay, step 2. You need to set up, well, I can't outline it. So here what's happening is you are creating a prototype So you're saying create a instance of the person's prototype and assign it to student prototype. So the create method is actually, what this is doing is creating an object. So this returns an object. And its prototype is person.prototype. So it's not copying. Create is not copying the object. It's not creating a copy of this object. It is creating a new object and setting the prototype property or field to point to person.prototype. Okay? So you will find if it were making a copy, if you were to change in person.prototype, if you were to change favorite color, let's say we change it to red, it will change in student will now find that favorite color is red. If it had created a copy, then changing favorite color to red here would not change the value of favorite color here. So again, I emphasize create is not creating a copy. It's not copying favorite color into there. Instead, it is setting the prototype property to point to whatever argument was passed to the create function. Okay, so you call create object dot create prototype, and it returns an empty object with the prototype field. I'm going to say prototype object here to make it clear, with the prototype field set to the prototype object. Okay, which establishes effectively an inheritance hierarchy. Because you now have a chain of prototypes. So now the student prototype effectively points up to the person prototype. So you're creating this inheritance hierarchy that way. And then the third step is that we have to change the constructor field. Why do we have to change the constructor field? Because right now we created an empty object. Therefore, if we invoke the constructor, it will be the person constructor. So we have to override the constructor property, store it locally, so that it now points to the student. If you think this is a pain in the neck, why, it certainly is a pain in the neck. Okay? So step 3 is change the constructor property of the new prototype object to be the constructor function for this class. Okay, 3 simple steps. Now, for those of you who use JavaScript, you may be thinking, but there's an easier way. And there is. So the newest version of JavaScript gives you, come on, where is it? Okay, there it is. Wait. This is, I'm sure that, how? This is one of those these moments where you're sure that the book had the newer syntax. Am I like dreaming? I swear I saw it too. Second. Let's exit presentation view. Maybe there's constructor functions, prototype objects, JavaScript, private properties, inheritance, Huh. There we go. It wasn't showing up in the presentation mode. Okay, so the latest version of JavaScript has implemented class stuff, but you need to know the old syntax too because there's a lot of legacy code that uses the old way. But the newer way, you just say class, then you say constructor, and it knows that it's a constructor. And you'll notice that your functions, you just define the functions without having to assign them to properties. You just give it, you don't even use the function keyword. Okay? And then if you want to extend a class, you just do it that way. And instead of having to explicitly name the superclass, you can use super. So the newer syntax looks very Java-like. And I'm fine with you using the new syntax if you want, but make sure you still do the challenge activities using the old syntax just so that you get some experience with the old syntax. Okay, but I'm perfectly fine with you using the new syntax. Any of the new browsers should support it. Okay, so any questions about this? This is kind of a mind bending. When I first saw prototype instance stuff, it was a bit mind bending for me. Okay, so the last thing I want to show you, and it has nothing to do with classes, but it is another common thing with scripting languages. So first of all, with arrays, JavaScript does give you multiple ways to get through, to loop through it. Okay, so you can just say for I equals 0, I less than groceries.length. That's one way. Another way is using, you may have heard MapReduce. Most scripting languages support so-called map operations that apply a function to every element of a vector. So JavaScript has a for each function associated with an array. And again, you are giving it an unnamed function. So it's one parameter is an unnamed function that takes an item and an index. So this is the value, this is the index. So for example, bread would be the item, its index is 0. Milk would be the item, index 1. Peanut butter would be the item, index would be 2. So basically, the for each function applies the argument passed in, which is a function that takes 2 arguments, and it executes it for each of the elements in the array. And this is a map operator. It's applying that function to every element of the array. So when you hear map, reduce, this is the map part of it. Okay? Reduce is something else. We won't worry about it. Okay. There are 2 other ways to iterate through arrays. So you also can use for in or for of. So mnemonic. So for in returns the indices 0, 1, 2, 3. So if you say for var I in nums, you'll get 0, 1, 2. If you say for var n of, you'll get the values. Just be careful what you write. If you switch the I and the O, you get 2 completely different values. Also, in was part of the original language. Of is part of the most recent JavaScript. So older versions of JavaScript don't support for of. Here's another nasty. It is not guaranteed that for var I in nums will return the indices in the order 0, 1, 2. It's not in the standard. It can be 2, 1, 0. It can be 1, 0, 2. It could be 0, 1, 2. You cannot be guaranteed that for in will return them in numerical order. You want them in numerical order? For loop. Okay? I think for each is also guaranteed to this for each function, I think is also guaranteed to return, to loop through it in the, from 0 to n minus 1, but not for n. It is what it is. Okay, so that is it. I guess it wasn't so short and so sweet. Sorry about that. I guess there was a lot more to talk about with classes than I thought. So make sure you do the challenge exercises. There's a bunch of them before Thursday's class, and I will see you on Thursday.